So you should have watched the calculator tutorial on how to take a derivative with your calculator. Um, so we're going to use that to apply Newton's method, okay? We're going to do it a little bit by hand, and then I'm going to show you how to use the calculator to speed up the process. And that's probably the preferred way of doing it and doing it fully by hand, okay? So here's our first example. Here's our function, f of x is equal to 2x cubed, let's see, minus 3x squared plus 2. Okay, there's our function. The question is asking us to use Newton's method with the specified initial approximation x1 to find x3, the third approximation to the root of the given equation. Okay, here is our actual function. But here's our problem. Here's our actual problem right here. We want to know when this function is equal to 0, because that's what it means to find a root. Okay, a root is an x-intercept, is a 0. These words are all synonymous here. Okay, so we use the initial approximation of -1. Okay. That is our initial guess. We're going to say that our function is equal to 0 at approximately -1, okay? So it's our job to find x3. Now, if you recall, this was Newton's method. X sub n plus 1 is equal to x sub n minus f of x sub n divided by f prime of x sub n. So what this is saying is that we need our initial guess. So to find x2, we need our initial guess, x1, minus we need the function value at x1 divided by the value of the derivative at x1. Then we're going to get x2. After we have x2, we repeat the process to get x3. And that's what the question is asking us for. What is x3? Alright, so let's see. Let's write this over here. x2 is equal to x1 minus f of x1 divided by f prime of x1. And like I said, we're going to do this one by hand, just so you could see the process of what's going on, and then we're going to use the calculator to help us. So we need the function value at x1. We also need the derivative. So let's erase this. Let me go ahead and find the derivative first. So f prime of x is equal to, now all of this is just power rules. Well, this is a constant, so it's 0. So 6x squared minus 6x. Alright, so now let's go ahead and find the function value, f of x1, and f prime of x1. So that's f of -1 and f prime of -1. So that is just taking -1, plugging into the function. That's taking -1, plugging it into the derivative. Alright? So if I were to plug -1 into here, let's see. I believe you get -3. You do get -3. I know I'm giving these values very quickly, but we will go over how to do them on the calculator. And that value is 12. Okay, so that's if I were to take these, plug it in, take this, plug it in, and output the values. Okay? So let's go ahead and calculate our second iteration. So our second iteration, x2, says take our first iteration, x1, -1, minus f of x1, which is -3, divided by f prime of x1, which is 12. So this is negative 1. Negative and a negative turn into a plus. 3 over 12 simplifies to 1/4. Negative 1 plus 1/4 is 3/4. So now we've got our x2. Or sorry, negative 3/4. Negative 1 plus 1/4 is negative 3/4. Alright, so here's our second iteration. Now let's go ahead and find our third iteration. Well, our third iteration says take x2 minus f of x2 divided by f prime of x2. Alright, we already have x2, but we need these function values here. Okay? So, I'm going to erase. I'm going to keep these because it has the same structure. x2, x2. Well, x2 happens to be negative 3/4, negative 3/4. And then if you were to plug that in, let's see, in fraction form, negative 17 over 32. And this one, it doesn't have a fraction form. 7.875. Or maybe it does. 7.875. $63 over 8. There we go. Alright, so now we can calculate x3. x3 is equal to, well, x2, which is negative 3/4, minus, because that's just how the Newton's method works, f of x2, which is negative 17 over 32, divided by f prime of x2, which is 63 over 8. Now, I'm definitely going to use a calculator for this. I mean, this is a messy fraction here. So, negative 3/4 minus negative 17 divided by 32 divided by 63 divided by 8. Now, make sure you're using parentheses around all of your fractions. That way, it'll come out correctly. Okay? Make sure you put parentheses around this numerator. Also parentheses around this denominator. When you hit enter, see, mine gave it to me in a fraction form, but then if I turn it into a decimal, negative 0.6825. Okay, as you can see, negative 3/4, that's negative 0.75. It went from negative 1 to negative 0.75 to negative 0.6825. Okay? I would guess that another iteration, I'd probably say it's probably negative 0.66, somewhere around there. Now, that's just a guess. I have no idea. We're not doing the next iteration, but you can see it's getting closer to some number. Okay? Now, let's go ahead and test it. Let's take this value and plug it into the original equation. And that's just that's what I'm doing on my calculator. I'm typing 2, parenthesis, this number, parenthesis, cubed, and plugging it in. And if I were to do that, so let me erase. So here's my x3. If I find f of x3, or f of negative 0.6825, that is equal to negative 0.0335. That's pretty close to 0, okay? Negative 0.03, 3/10, okay? That is really close to 0. Now, if we keep going, it'll get closer and closer to 0 because this will get closer and closer to the actual root of the equation, okay? Now, this equation could have more roots. We could try a different x1. A different x1 may bring us to the same root, okay? So this is getting closer to some negative 0.6 number. A different starting point may bring us to the same answer, okay? Now, if that happens, you just got to choose a different starting point far away from this. That just normally means you are really close to the same value for your starting point, okay? So now let me show you how to use the calculator to speed up this process.